the video. Thank you. Hi children and viewers. In previous video we discussed about the what is electromagnetic wave and what is electromagnetic spectrum and what is the arrangement of different type of electromagnetic waves in an electromagnetic spectrum. Okay children, up to now you didn't see that particular video. I will provide the link of that particular video in this description of video. Clear children? Children, in this video I am going to explain Bohr's atomic model and its limitations and how the Bohr's atomic model is corrected by the Sommerfield. Okay children, so almost all I think so you learned something about the atomic structure in our previous 9th class. So here in this video we are going to discuss same thing. Okay children, without any late I am going to the topic. So children, from this onwards very important concepts, because these concepts are very useful to up to laws of where we can learn the chemistry, there you can utilize these concepts. That's why you have to watch very carefully children. So children, Bohr explained the structure of atom. For that he given some key points. So in that the first thing is Bohr explained the electrons are revolves around the nucleus in particular orbitals. Those are circular orbitals. So according to the Bohr, first thing is what? All the electrons are revolves around the electrons in spherical orbitals. Spherical orbitals. Clear children? So like this. So this is the nucleus. Around the nucleus the electrons are revolves around in particular shell. So this is the location of electron like this. So first thing is what? According to the Bohr, the electrons revolves around the nucleus in particular orbitals. So those are in the shape of spherical or circular, and he was given name that those orbitals are the stationary orbits. Stationary orbitals. Clear? Stationary orbital means when the electrons revolves around the nucleus in particular shell or in particular orbital. Up to what time that should be revolves in that particular orbital, there is no loss of its energy. Clear? According to the Bohr, while an electron revolves in particular orbital, then there is no loss of any energy. Either it is absorption or emission of energy. Clear children? So by explaining that, he was given explanation for that why the electron is not fall into the nucleus. Okay children, so that is the limitation of Rutherford atomic model. So according to the mechanics, what's that? While any electron it is in revolution or rotation, every moving object or every moving particle loses its energy. So that is the fundamental of mechanics. So but here Rutherford is failed to explain why the electron does not fall into the nucleus even though that should be revolving continuously. So according to the fundamentals of science, every moving particle can lose the energy. So while it can lose the energy, the electron must be fall into the nucleus, but it does not happen. That should be corrected by the Bohr by giving the definition of stationary orbits. Stationary orbits means that while an electron is revolving in particular one orbital, it does not lose its energy. So this is the explanation of the Bohr why the electrons do not fall into the nucleus. Okay children, and children, he was given name of those particular orbitals, given that name as K, L, M, N. KLMN. Okay children, so he was given names to be like this. This is the nucleus. Around the nucleus we have some particular shells are there. So he was given name like this, KLM, and if you can take it is N. So he was KLMN. Here while KLMN, while we are going from nucleus to the in this direction radially outwards, then the energy of the shell should be increases. Okay children, so here KLMN shells are there. For them he was given like this, N is equals to 1, that means that is the K shell. Here N is the principal quantum number. What is that? Principal quantum number. When N is equals to 2, that represents the L shell, and N is equals to 3, that is M, and when N is equals to 4, that is N shell. So children, according to the Bohr, if any electron is in particular one shell, for example here we are taken one electron is in L shell, that should be continuously revolves. That should be continuously revolves. Clear? So here electron it is there. While the electron, that particular electron in that particular shell, when it is in revolution in that particular shell, there is no emission of energy, no absorption of energy. Clear children? While for example if you are given some additional energy to the electron, then electron will absorb the energy, that should be excited and moving to the higher energy states like M. Clear? In this case the energy should be absorbed. Clear? When certain amount of energy, additional energy given to the electron in particular one shell, then absorption of energy takes place, then that should be moves from lower energy level to the higher energy level or high energy shell. So when it can reaches the high energy shell, then it becomes unstable. It becomes unstable there. Again, to get it stable, the electron must be tries to comes down. Clear? During that again that should be comes down to the again same shell by emitting certain amount of energy. In this case emission takes place. According to Bohr, when any electron absorbs the energy, that should be excited and that should be shifted from lower energy shell to the higher energy shell. Generally lower energy shell can be considered as the ground energy or ground level. So when we are giving some energy to the electron which is in the ground level, that should be absorbs the energy, that should be excited and that should be goes to the higher energy shell. Clear? In this case absorption of energy should be takes place. Clear children? And once children electron should be in the excited level, it becomes unstable because it is having some additional energy. Again, to become the neutral, again the electron should be comes down. That should be, it is jumps from higher energy level to the lower energy level. Clear? While it is coming from higher energy level to the lower energy level, during that process some energy is emitted. During that process certain amount of energy is emitted. That is what we call emission. If that particular emission of energy should be captured on your screen, that should be gives the a line spectra. What is that? Line spectra or line spectrum. Okay children, so scientists can observe that every element has its own colors. Every element can emit its own colors. How? Because of emission of light. How the emission of light should be takes place? When the electron should be jumps from higher energy level to the lower energy level. Clear children? So in this entire thing you have to observe that according to the Bohr, while electron can jumps from lower energy level to the higher energy level, absorption takes place. When electron is jumps from high to the low, emission should be takes place. So that's why here, while electron is in particular one shell revolution takes place, then there is no emission and no absorption. When it is jumps from one level to the another level, then only either it is absorption or emission should be takes place. The energy what it is emitted, that should be written as some like h nu. Okay, clear children? So that is the third one. And fourth one, children, here Bohr's atomic model successfully explain the spectrum, lines of spectrum of hydrogen. Clear children? So here in this case, in our textbook it was clearly mentioned that children, here the hydrogen spectrum can consist of line spectra. So children, this is the one. Hydrogen spectrum should be like this. Here this entire thing should be shown with some black color. So black color represents, means that is the energy is absorbed, children. Clear? And in middle we are having some lines of different colors. Clear children? So to understand that, simply I am drawing here one line. So it is mixed with the background color, that's why here I am simply showing them like lines. Here this is the line spectrum of hydrogen. So that means here in line spectrum, these lines represents the emission of light. Clear children? And the background black color what we are finding there in our textbook, that should be explains the absorption. That is what? Absorption of spectrum. So clear children? So according to this concept, what's that? While electron is jumps from higher energy level to the lower energy level, the energy emission takes place, and in case of hydrogen also same thing happened. During that, simply was given that the spectrum of hydrogen should be like this. Here the emission of light should be takes place like in form of lines. The color lines what we are finding in the spectrum, that should be represents the emission of particular color or particular wavelength. Okay children, so this is simply about the Bohr's atomic model. And children, according to Bohr's atomic model, the successfully explains about the formation of hydrogen spectrum. So for this atomic model, there is some demerits also there. What's that? The line spectrum of hydrogen, what he was given one thing. So even that spectrum is observed by using a high resolving spectroscope. It is not a single line. Again, that line is consists of more number of lines. So it is not a line spectra. Clear? According to the Bohr, it is the line spectra. So it was given explanation improperly. But when the line spectrum is observed by using the high resolving spectroscope, they are not in line. Every line consists of so many energy levels, so one line should be in form of group of lines. So it is the failure. And Bohr atomic model can explain only for hydrogen only. It will not even explain for the more than number of the atoms which are having more than the atomic number of hydrogen. So these are the demerits of Bohr's atomic model, mainly children. Clear? According to the Bohr, all the electrons should be revolves in the atom in the surrounding of nucleus. How it is? In circular orbits or spherical orbitals. That's the first thing. And second thing is what? He was given one concept of stationary orbits. According to the concept, while an electron revolves in particular orbital, there is no emission and no absorption of any energy, and simply there is no loss of energy while the Shibi revolves in particular one orbital. That's why these orbitals are called stationary orbitals. This is given explanation for that why electron is not falling into the nucleus of an atom. And children, next thing is what? While electron is jumps from lower to the higher energy level, then absorption of energy takes place. While electron is jumps from higher energy level to the lower energy level, then emission should be takes place. And the energy what it is emitted in form of energy packets, it is very clear. And next children, here children, that should be detail explained in detail later. How what is the energy packet, how it is, we will discuss later in next coming videos we will discuss. And children, according to the Bohr, the hydrogen spectrum should be like this. The hydrogen spectrum consists of multiple colors of lines. Those lines are based upon this concept only. And children, what are the demerits? He was unable to explain the spectrum formed by the different atoms which are having atomic number more than 1. And even though he was explained something about the line spectrum of hydrogen, when it is observed through a high resolving spectroscope, these are again lines consist of multiple lines. Okay children, that's about the Bohr atomic model. So children, so to explain the Bohr atomic model, Sommerfield can modify the Bohr atomic model. What I told you, the lines which are in the hydrogen spectrum, they are not individual lines, they are having again multiple lines. To explain the spectrum of hydrogen, Sommerfield can modify the Bohr's atomic model. Clear? In such a way that he was given one concept. That concept is here. He is introduced the concept of elliptical orbitals. He introduced the concept of elliptical orbitals. But according to the Bohr, they are spherical or circular orbitals. And next thing is here children, the orbitals may be circular or elliptical. According to Sommerfield, the orbitals may be in circular or elliptical. Okay children, and third one children, the elliptical orbital, if you are taken, this is the elliptical orbital, this is the one elliptical orbitals. For that elliptical orbital, he was given two axes. This is the major axis and this is the minor axis. If it is an elliptical orbital, here this is the major axis and this is the minor axis. Clear? So in case of a circular orbital, major axis radius and minor both are equal. So in this case children, this is what major axis or major, and this is what minor axis. So for elliptical orbital we can consider major axis more than the minor, but we can consider a circular orbital. For that these two are equal. So he was given one concept like that. Clear? So when we have that type of elliptical orbital, automatically the radius and angular momentum both should be changes. And children, next thing here, what I told you, the energy what we are taken, that should be angular momentum consists of nh by 2 pi. Angular momentum should be, in this case, the angular momentum should be taken as L is equals to nh by 2 pi. Here n value is 1, 2, 3, 4 and so on like that. But it is not equals to 0. Here for example, you are taking some kh by 2 pi. Here k value you are taken 1, 2, 3, 4 and so on like that. But here k value is not equals to 0. That is next thing. And next children here. So we are taking h by 2, integral multiple of angular momentum is integral multiple of h by 2 pi. And children, next thing here, fifth point. While we are moving, K, L, M, N. We have number of shells there in Bohr orbital. So while we are moving from higher energy shells, then when the number is increase, n value is increase, n is equals to 1 2 3 4, when the n value increases, the nature of elliptical should be decreases. Clear? When the principal quantum number value is increases, n is equals to 1 2 3 4 like that, then the nature of elliptical should be decreases. Clear, children? And now he was introduced the one quantum number, that is azimuthal quantum number. What's that? Azimuthal quantum number he was introduced. And children, he was given one concept of sub-energy levels. So these sub-energy levels are the responsible for the formation of group of lines in a spectrum. Clear? He was introduced the concept of sub-energy levels. So these sub-energy levels are the responsible for the formation of group of lines in a line spectrum of hydrogen spectrum. So he was successfully explained why the number of lines are consist of in a line spectrum of hydrogen. But the failure is he is also unable to explain line spectra or spectrum of different atoms which are having atomic number is more than 1. That means he also given correct explanation for only hydrogen atom. He is not able to explain the spectrum formed by the different type of atoms for atomic number which are having more than 1. So this is about, children, Sommerfield correction for the Bohr's atomic model. That's why it is commonly known as Bohr-sommerfield model. Bohr-sommerfield model. Children, look here. See once again, Bohr's atomic model should be modified by the Sommerfield. That's why it is famous or known as the Bohr-sommerfield model. Clear? According to the Bohr-sommerfield concept, Sommerfield introduced the concept of elliptical orbital. That is the first thing. Clear? And according to his postulates, the orbital may be either it is circular or elliptical. And third one is, while we consider elliptical orbital, then elliptical orbital should be consist of major axis and minor axis. When we are considering the major axis and minor axis, the radius vector should be different at different positions of electron. The radius of the electron should be different for different situations. And children, the angular direction of angular momentum also changes when we consider elliptical orbital. Clear? But in case of circular orbital, according to Bohr, the radius is same. That means what? If we can consider, this is the, according to the Bohr, whatever, children, this is the Bohr spherical shell or stationary orbital. If you can consider this is the position of electron, this position electron is there, then here R is same. And if it is at this position, here R is also same. But in case of elliptical orbital, if electron is there, then the radius is more. And if the electron is at this point, the radius is less. So that's why here, whatever the children, the major axis, minor axis concept is involved in the case of elliptical orbital. That's why here the radius should be varies and angular momentum also, direction of angular momentum also varies. And in case of circular orbital, semi-major axis, minor axis, both are having same. And next, children, in case of KLMN, what I told you previously, Bohr suggested n is equals to 1, that is K shell, n is equals to 2, that is L shell, n is equals to 3, M shell, n is equals to 4, N shell. If shell increases, the size of the elliptical should be decreases. Clear? And next, children, what is, he was introduced the concept of sub-energy levels. And he was introduced the azimuthal quantum number. Sommerfield introduced the sub-energy levels and azimuthal quantum number. The emission of energy should be depend upon the number of sub-energy levels. So children, I will give one diagram for you, then maybe you may get one clarity regarding the sub-energy levels. So children, it's very easy thing. So children, watch carefully and focus concentrately, children, because of this is one important one. Children, we have K, L, M, N shells. So for K is equals to what you have, N is equals to 1, and for L shell what you have, N is equals to 2. For M shell what you have, N is equals to 3. For N shell it is what, N is equals to 4. So children, what we discussed in case of Bohr, K, L, M, N, like that. So here for N is equals to 1, he was given some L values. L means angular quantum number, azimuthal angular quantum number. For N is equals to 1, L value is 0. Clear? For N is equals to 2, L value is 0, 1. For N is equals to 3, L values are 0, 1, 2. And for N is equals to 4, L values are 0, 1, 2, 3. Clear? So L is equals to 0, N is equals to 1. L is equals to 0, 1. For N is equals to 2, it is the L shell. For that, sub-energy shells are what? 0, 1. And for N is equals to 3, sub-energy also are 0, 1, 2, 3. And for N is equals to 4 shell, we have L is equals to 0, 1, 2, 3 subshells. So N is equals to 1, N is equals to 3, N is equals to 4. These are main shells, what we call this main shells. And now what I am writing, these are the subshells. So main shell is given by the principal quantum number, and subshells is given by the azimuthal quantum numbers. L is equals to 0, L is equals to 0, 1 for N is equals to, L is equals to 0, 1, 2 for N is equals to 3, and L is equals to 0, 1, 2, 3 for N is equals to 4. Clear? Children, based upon this concept, 2 marks questions, 1 mark questions will be asked in public examinations. For N is equals to how many s orbitals or how many elliptical orbitals are there? How many elliptical and how many circular orbitals there? So let's go for that. So that's important for 2 marks and 1 mark question also. So you have to watch carefully, children. First thing, I am going to draw all the subshells and sub-energy shells for these 4 things. Here, children, N is equals to 1. This is what? N is equals to 1. Here, this is the N is equals to 1. For that, L value is what? 0. Clear? So, children, L is equals to 0 means that is s orbital. In next coming video, we will discuss very clearly. L is equals to 0 means what? S orbital. Clear? So, L is equals to 0. And next, now N is equals to 2. N is equals to 2. Now for N is equals to, how many we have? L value is 0 and 1. L is equals to 0 and 1. And this is initially what we say, this is L is equals to 0. L is equals to 0, that is circular. That means this is the s orbital, spherical in shape. And this is also spherical in shape. So L is equals to 0 always in spherical shape. Clear? L is equals to 0 is there. Next L is equals to 1. So this is the elliptical now. L is equals to 1. Clear? For N is equals to 1, L is equals to 0. For N is equals to 2, L is equals to 0, L is equals to 1. Clear? So one is s orbital and one is p orbital. Later we discuss. Okay, clear. L is equals to 0 and L is equals to 1. In examination point of view, for N is equals to 2, for N is equals to 2 shell, how many spherical orbitals there? How many elliptical there? How many elliptical? 1. How many circular or spherical? 1. So the question will be asked like that. And now children, N is equals to 3. N is equals to 3. So now here in this case, when the N is equals to, for N is equals to 3 shell, how many circular there? How many elliptical there? Let's go for that. First thing is what? L is equals to 0, that is spherical shell. So for N is equals to 3, we have what are the values of L? 0, 1, 2. 0, 1, 2. So 0 is over now. So this is what? L is equals to 1. Clear? And next, this is the L is equals to 2. First thing is what? This is L is equals to 1 and this is L equals to 2. Clear, children? So for N is equals to 3, how many circular there, spherical there? 1 spherical, 2 elliptical, like that. And children, now if you go for N is equals to 4, N is equals to 4. When N is equals to 4, how many values we have? S. L is 0, 1, 2, 3. 0, 1, 2, 3. So initial one is L is equals to 0, children. Initially L is equals to 0. Now what you have to say? This is L is equals to 1. Clear? L is equals to 0 over, L is equals to 1 over. Next L is equals to 2. This is what? L is equals to 2. Clear? And next thing is, this is L is equals to 3. L is equals to 3. So in this case, 1 spherical is there, 3 elliptical. So that's why in examination point of view, the question should be like this. For N is equals to 1, how many spherical shells there? How many elliptical there? Here how many spherical? 1. How many elliptical? 0. When N is equals to 2 shell, for K L shell, how many spherical there? How many elliptical there? How many there? 1 spherical, 1 elliptical. And for N is equals to 3, how many spherical there? How many elliptical there? Spherical is 1, elliptical is 2. Total how many there? 3. And similarly now N is equals to 4. Then 1 spherical is there, 3 elliptical is there. So in this way, children, he was given concept of the sub-energy levels. Sub-energy levels in our textbook also it was given very clearly. These sub-energy levels are generally here in this case. They are explains the how the spectral line of hydrogen spectrum consists of group of lines in a one line of spectrum. So that is the reason. Based upon this only, so he was successfully explained in hydrogen spectrum how one line consists of group of lines based upon the energy level concept. So he was introduced like that. So generally L is equals to 0 means that is s orbital, L is equals to 1 means p orbital, L is equals to is d, and L is equals to 3 means f orbitals. So in coming videos we will discuss in detail. Okay, children, I hope you understand. Bohr-sommerfield is successfully explaining the spectrum of hydrogen atom, but the concept was not explains the spectrum formula, the different type of elements which are having atomic number more than the hydrogen atom. So it is the failure for that situation. So I hope you understand. We will meet in the next video with some other interesting topic. Bye. Take care, children.